Hi, this is Pythagorean Theorem, Part 1. Not only is it an awkward word to say, Pythagorean Theorem, but man, there's vocabulary up the wazoo on this one. So, this first part, I'm more interested in knowing, or at least teaching you, who wrote this thing. So, let's dive into that a little bit first. So, first off, who wrote the Pythagorean theorem? And I'm going to do this. I'm going to do the ultimate. I'm going to check it on Wikipedia. So please type in Pythagorean theorem and you will see all sorts of crazy things about this guy. Let's see. Yeah, it is named after the Greek mathematician Pythagoras, who by tradition is credited with its discovery and proof. So this guy Pythagoras was like this crazy mathematician, and you're like, that guy wrote it. However, although it is often argued that the knowledge of the theorem predates him, that it came before him, there is evidence that the Babylonian mathematicians understood the formula. Now, I'll just give you a little bit of math history. The Babylonians were crazy smart. I mean, like, you know how we go 1, 2, all the way to 9, and when we get to 10, well, we added 1 right there and put a 0, and then we start counting again. Like, that method of counting, they didn't do that. They had 66 numbers. So instead of 1 through 9, they had 1 through 66 symbols. And then they like rotated. Like, isn't that insane? Babylonians were ridiculous about their math. So they're probably the ones that came up with it first, but he came up with it on his own. And as all things, whoever wins a war writes the history. So true statement. So I'm gonna write that guy's name. It's let's see, what was it? It's Pythagoras, Pythagoras. Has credit, but who probably wrote it? The Babylonians did. I'm going to look that up just because I'm a horrible speller. Babyloниans. Babylonians. Found it first. So maybe he found it on his own. And this has happened before, like calculus. Everyone's like, oh, Isaac Newton, the father of all calculus. He found it the same time a German guy found it. And actually the German guy, the way he does it is the way we do it, but everyone likes Isaac Newton better because he has a cooler name, because no one knows how to speak German nowadays. Von Woltenstern. I'm going to come up with something, and somebody named Smith is going to come up with it also, and they're probably going to get credit for it because he has an easier name. So sad. Pythagoras is given credit for it. So who's this Pythagoras guy? What influence did Pythagoras have? That's a great question, I think. Well, let's Wikipedia him too. Let's see. He was a Greek philosopher, mathematician, and founder of the religious movement called Pythagorean theorem. So, like, he was a philosopher. I'm gonna write that down. He was a mathematician. So am I. So I'm covered under that one too. I'm not much of a philosopher. I'm really bad at that. And then he like was a religious guy. He had a religion named after him. So I'm gonna put religious leader. So I don't want to talk too much about religions because religions is always that touchy subject. But it's kind of interesting to look into what his, like the religion that he created, this little cult of mathematicians, because it wasn't just, he wasn't the only mathematician. It's pretty crazy. So they're like all these crazy mathematicians, and I've got all this different things. So let's go along over here. Well known in antiquity, that means into history, for the vegetarianism, for being vegetarians. No. Before vegetarian was a word, it was called the Pythagorean diet. These guys, this guy led a group of people that before it was called being I'm a vegetarian, I'm on the Pythagorean diet. That's what it was called when you don't eat meat and fish. And then somebody decided to come up with that. It's always funny that the prohibiting the consumption or even touching of any sort of bean, that's always the thing that drives me up a wall. They didn't, no beans. We can't even touch them. No meat, no fish, definitely no beans. Like, these, just ridiculous. However, views on women. Women were given equal opportunity to study as Pythagoreans and learned practical domestic skills in addition to philosophy. Like, they were still, like, this is still back in the day that they were very different and this and that. But they were allowed to study math too. Like, they believed, yeah, if you're a woman, you can study math. Isn't that interesting that, like, women's rights just barely happened in the 1950s in America? But back in the Greeks, if you're a woman, you can study math. You're welcome to study with us. Like, isn't that just crazy? So, and there's all sorts of things. I will high five you and give you a raffle ticket. If you find something in here, write down something like this. So this is a little extra credit raffle ticket type thing. I'll give you a raffle ticket if you find something that's crazy on here. I'm not going to go through it all. But these guys were ridiculous. They were really, like, they were crazy smart. The idea behind the Pythagorean theorem is that he didn't come up with it by himself. It was this group, this religious group that he led, and they found it together. So it's actually the first time, like, women were allowed to study math. A group of mathematicians were working together. That doesn't happen that often. Like, at least it didn't that happened here. And then it didn't happen until, like, the 14th century. It didn't start happening again. Everyone was on their own, doing their own thing, and not talking to each other. So it's just crazy. It's just wild. Like, look it up. Pythagoras and Pythagorean theorem. I'm sorry, you can't talk about the Pythagorean theorem and not give a little bit of the history on it, because these guys were just ridiculous. So that's my first little bit. All right, let's talk about what is the Pythagorean theorem. Well, first off, the Pythagorean theorem has to do for every right triangle. I gotta talk a little bit because I drink a little bit of water. Water, love it. For every right triangle, this is true. It is also a backwards thing. That's gonna be on part 3. There's actually 3 parts to this section. Where if this is true for a triangle, it's a right triangle if this law holds. So we're first going to work one way, then we'll work the backwards way. That's called an if and only if statement. Don't worry about it. I'll talk about that later. Okay, for every triangle. So we need to come up with some vocabulary. So I can't just give you the theorem. I got to warm you up. If this is a right triangle, clearly that's the right angle. So let's talk about a few things. First off, A and B are called the triangle's legs because they create, and yes, there is an E on the end of create. There's an E right there. So A and B make the right angle. They are right here, obviously. That's A, and that's B. So they are what make the angle. They are what makes the right angle. And they're huge. So that's always a basic thing to know. And then the very second part, C. Well, what's C? C is a very special thing. C is called the hypotenuse. So it is opposite of the right angle. So it doesn't create the angle. It's not a part of that angle right there. It is opposite of there. Some things to go with also, some basic facts. The hypotenuse is always the longest. It is bigger than A and B. A and B could be equal, but C has to be the biggest side for it to be true. That goes along with, like, these angles are smaller, so they don't open up as fast, whereas this angle is huge. So it opens up really fast. Don't you love it when I point the screen and I realize, oh, right, you can't see that. This angle is the biggest. That's why the hypotenuse is the biggest side, because the angles and relations with the sides, it all matters. You'll learn about that in trig. So, what is the hypotenuse theorem? The hypotenuse theorem is this. If it is a right triangle, I can square the legs together. So a squared plus b squared. These are the legs. And the order doesn't matter. We can get them backwards. It could have been b squared plus a squared. It doesn't matter. The legs don't, like the legs, as long as they're the legs, that's all that matters. A squared plus b squared, they are the smallest sides, are equal to the hypotenuse squared. So c squared. So this is the second equation of 7th grade. The first equation was distance equals rate times time. This is the second time that you see an equation, and this is just huge how much it's used. So that's that. Let's actually do 3 examples real quick. Just focus on A first, or example number 1. What is find x? Let me show you something on that real quick. Funny math jokes. Oh, it won't let me go. Come on. How about images? Haha. Oh. Please? Maybe? This is a funny joke. Find x. Here it is. Don't write that on a test. Not funny. Horrible joke. Well, it's an old joke, but that's not funny. That's not what they're asking for. So don't you be silly. So we're gonna. What is x's value? Okay, here we go. If I have 3, say that's 3 units and this is 4 units, the first thing I have to know is, well, if this is x over here, that's my unknown side. First off, I have this great equation, but I need to know what equals what. I can put 3 for a or 4. It doesn't matter. I'll put 4, 3. You can do it the other way around. And I'm going to say c is equal to x. It is a right triangle, so I am going to use the Pythagorean theorem. So I'm going to start with that. A squared plus b squared is equal to c squared. First thing I'm going to do. Okay? Well, a squared, well, I'm just going to plug everything in. This is 4 squared plus 3 squared. And this is x squared. That's what c is. Because x is the hypotenuse. 4 squared is 16. 3 squared is 9. By the way, what have I not done so far? Balance line, please. This is still x squared. Nothing's going on with x squared. So I know x squared, I'm going to do a little. X squared is equal to 25. So we've come to the part where now we actually have to use an operation on both sides. Remember, whatever I do on one side, I have to do on the other. Because I don't want to know what x squared is. I want to know what x is. Okay, well, if I square root both sides, that tells me x is equal to 5. Because the square root of 25 is 5. So x equals 5. That's us using the Pythagorean theorem and also using what we've learned with square roots, like that all coming together. So there you go. B. Again, I'm going to write down what's what. I need to know what A is equal to, I need to know what B is equal to, and I need to know what C is equal to. A is equal to 1, B is equal to 1. It doesn't matter which one's which, right? It's 1. N, well, that's C. So again, I'm going, and if you want to start it like this, with C squared equals A squared plus B squared, you can, that's fine. So I'm going to, because notice how I switched it up here. Might as well. This is 1 squared plus 1 squared. Well, that's 1 plus 1, isn't it? Well, that's 2. So my question is, well, we square root both sides. I am square rooting both sides. I show that as an operation. So C equals the square root of 2. Now, With the calculator, we could actually see what that equals, and that'd be great. But it is what it is. C is equal to the square root of 2. So there you go. C is equal. Sorry, not C. We were supposed to plug in n, right? So n equals the square root of 2. So that should have been n. But you get the idea. So that's us definitely using the Pythagorean theorem. What if I give you? But there is another way of using it. Hi, this is going to be the other way of using it. So here we go. I know 13 is the hypotenuse. So the hypotenuse has to be C. There's no getting around it. A and B, you can choose what you want. I'll put 12 on A, and I'll say B is W. You don't have to. You can put W up there and 12 down here. It doesn't matter. But C has to be the hypotenuse. There is no other way about that. So we have, I'm just going to plug stuff in. We have 12 squared plus B squared is equal to 13 squared. And now I just solve it. Oh, sorry, W squared. A little better. 12 squared is 144 plus W squared is equal to 169, right? So I want to get W by itself. Well, let's focus on W squared first. This is positive 144. So I'm going to add negative 144 to both sides. This is 0. So W squared equals, I'm basically subtracting, right? 9 minus 4 is 5. 6 minus 4 is 2. 1 minus 1 is 1. So now I have W squared equals 5. You seeing it? I'm seeing it. You seeing it? I'm going to rewrite, because I'm going to change it now, but I want to square root both sides to get W by itself. So W must equal to 5. So up here, W equals 5 is my answer. So there you go. Another example where we get an integer as an answer. We don't always get nice, pretty numbers. Sometimes we'll get those irrational numbers. When they are all rational, it is called a Pythagorean triple. I did want to say a little bit about someone getting killed. Back in the day, the cult developed this theorem, or he came up with it, but they believed all these numbers had to be rational numbers. They didn't believe in the square root of 2. Like, some guy drew it in the sand, they'd come up with this formula, and he's standing like, this number is not a real, this is an irrational number, what is this? And they said, that has to be a rational number, and they killed the guy. That really happened, look it up on there, but that's a true statement. Math kills, so does meth, don't do either. Well, do math, don't do meth, as I say. Have a great time, enjoy this video, bye.